EDX Core Pure, Matrices 4, Determinants and Inverses of 3x3 matrices, Minors and Cofactors of a 3x3 matrix. Calculator use and inverse of a 3x3 matrix. How to do this without a calculator has been covered, as you may come across matrices with some algebraic variable rather than numeric constant elements. So if we consider a 3x3 matrix A using the notation below, so A equals A1, B1, C1, etc. So the columns are A1, A2, A3, B1, B2, B3, C1, C2, C3. That's the convention we're going to be using. The minor of a particular element of a matrix is found by eliminating the row and column of that element and then finding the determinant, whether it's positive, negative or zero, of the remaining matrix. So for a 3x3 matrix, when we eliminate the relevant row and column, the remaining matrix would be a 2x2 matrix. A minor, together with its correct sign, is known as a cofactor. So each position of the 3x3 matrix has been designated with a sign, and it goes plus, minus, plus, minus, plus, minus, plus, minus, plus. And a cofactor is always denoted by a capital letter. So here we have a 3x3 matrix P, and we want to find the minor of element A1. So this is what it would look like. So this is element A1, so you would do this after practice. You do this as like a mental exercise as you're going along. There's element A1. So you eliminate the row and the column containing A1, and you look at the remaining 2x2 determinants. That's minus 3, 4, 7, 2, which is minus 6, minus 28, so that's minus 34. So that's the minor of the element A1. Hence the cofactor for the element A1 is minus 34, because it's in the position in the matrix that's assigned with a positive sign, and once we've found the cofactor of that element, it's called capital A1. As you can see there, and we can see how we've assigned it with the plus sign. However, if we now look for the minor and the cofactor of element B1, so here's B1, so we cross out that row and that column, and we look at the determinant of the remaining 2x2 matrix, minus 5, 6, 7, 2. So that's minus 10, minus 42 equals minus 52. So that's the minor of element B1. However, when we look for the cofactor, which is going to be called capital B1, we know the minor is minus 52, but the position of B1 in this 3x3 matrix means that it has been assigned with a negative because of its position. So the cofactor of B1 is in fact plus 52, as we can see there. So if we were looking for the minor of element C2, we would cross out the row and the column comparing C2, and when we looked at the 2x2 determinant, which is in this case the determinant of 3, 6, 2, 4, we get 0. So it is possible for the cofactor of an element to be 0. So here we have a 3x3 matrix. Notice the sign allocation for each element, and the ones you've got to watch out for are the ones in this diamond position. These four are the ones you've got to be careful with. And you may want to pause the video at this stage to see if you can find the cofactor, all 9 cofactors for the 9 elements in matrix A. And the answers you should get are displayed there. Notice the capital letters because they have been cofactors, and notice how B1 as a minus in front of the determinant, and so does C2, A2 and B3 due to the position of those elements in the matrix. In the next session we're going to be looking at the determinant of a 3 by 3 matrix.